Hi everyone, this video is still on the motion equations. But in this video we're going to look at a question that I consider actually really difficult and may give a few people problems when they first come across it. And I call it the rocket debris question. First of all, I'm going to explain the setup of this question, as in what's happening to this rocket and the debris. And then I'm going to put forward the questions we want to answer, and then I'll work it out all the way through all three answers. So there's this rocket sitting on a launch pad, and that rocket fires its engines and begins accelerating upwards. So at a certain time later, the exact time later is not important, the rocket is at, we'll say, a height here, or a displacement from the ground of 3,000 meters. Meters is equal to the displacement, and it loses a part of itself, some kind of debris. We'll say that fin comes off, and that fin is then no longer being pulled upwards by the force of the engine of the rocket. It's actually going to be accelerated downwards by gravity. So at a certain time later, this bit of debris is going to hit the ground over there. Now most people, even those who have no experience with physics equations, are able to show the shape of the path that fin will take. Rarely will you see someone say the fin will drop down like this, because that would be very wrong. The fin has already, because the rocket is travelling upwards, some kind of velocity in that direction. So the actual path the fin will take will probably look something like that. So the final detail I'm going to add is the exact vertical velocity of the rocket at this time. The vertical velocity is equal to 330 meters per second. So that will also be the initial vertical velocity of this fin here. Ignore all horizontal motion. I only draw the fin moving sideways like this to give you an idea that it has to go up before it comes down again. It won't immediately start dropping down because it does have that initial velocity upwards, which gravity will try to counteract after a little while. So, the three things we're going to try to find. 1. What is the max height of that fin there? 2. What is the total time the fin takes to drop to the ground there? And 3. What is the velocity, I'll just put a bracket, only considering vertical, upon impact with the ground? So the first one I think is the easiest to answer. What is the max height? The first thing we need to recognize is as soon as this fin comes off the rocket, it's going to be acted on by gravity. The rocket is being acted on by gravity, but the engines are much stronger than gravity, so the rocket is still accelerating upwards. The fin has no engine, so the acceleration on that fin, ignoring air resistance, is going to be, in physics, in year 12, we say 10 meters per second down like that. Or, if I can avoid drawing that arrow, I will. The acceleration is simply negative 10 meters per second squared, since we've already basically defined positive velocity in the upwards direction. So we have this negative acceleration going on. And at the max height of the fin, this magical moment here at the top of that curve there, we know the velocity of that fin is going to be 0. So if the initial velocity here of the fin was the same as the rocket, which it would be if it did pop off without much of a jolt, the initial velocity is 330 meters per second, the final velocity is 0, so we can find the displacement, so the amount of distance in a straight line this fin has covered in a vertical direction before it stops. Let's use this formula here because we know A, we know U, we know V, and we're just trying to find S. So getting S by itself, V squared take U squared over 2A is equal to S. We come up with 0 squared take away 330 squared divided by 2 times negative 10 gives us a total of negative 330 squared divided by negative 20, 5, 4, 4, 5 meters. So the fin travels an additional 5 kilometers vertically before it turns around here, ignoring air resistance. That is not to say the fin is 5,445 meters off the ground. Only that from this point, it traveled a further 5,445 meters vertically before it came to a stop. That means that its total height, so the max height, is equal to the initial height of the fin there, so 3,000 meters, plus that little bit extra that it flew up, actually a lot extra, 5,445 meters, which comes to a total of 8,445 meters. So this fin, even though it's being accelerated down quite quickly by gravity, is still going to keep flying up quite a lot before it comes crashing back down to Earth. The next part of the question we want to work out is the total time it takes for this fin to hit the Earth. And we're going to do that by considering 2 separate times. First of all, the time it takes to reach the max height, and then we add that on to the time it takes to fall down from that max height to the ground. So let's figure out the total time it takes for this fin to come to a stop up there. We know at the top the final velocity is 0, so we know V, we know U, we know A, but we don't know T. So let's get T by itself there. V take away U on A is equal to T, which is equal to 0 take away 330 divided by A, which is negative 10. So we get 33 seconds of motion of that fin. So it takes 33 seconds for that fin to lose all its vertical velocity. And then it begins to fall. We know it has to fall a total distance of 8,445 meters. We know its initial velocity is 0, and its acceleration is, in this case, since we're taking the distance it's falling to be positive, the acceleration is positive 10. Let's see if we can find a formula that links all those up. S equals ut plus half at squared. We'll try to get t by itself here. So recognize if the initial vertical velocity at the top there is 0, this term is effectively cancelled out. So we have s is equal to a half at squared, or 2s over a square rooted is equal to t, rearranging this formula here. And this comes to the square root of 2 times 8,445 divided by 10. In fact, I might say that's negative 8,445 because it is in the negative direction. That way I can make my acceleration negative 2, which comes to a total of 41.1 seconds. So that is the time it takes to fall from the top there all the way back to the bottom. That means the total time taken for the journey up and then the journey down is equal to 33 plus 41.1, which comes to, so total time is equal to 33 plus 41.1, or 74.1. Oops, 74.1. Finally, the velocity upon impact. If this answer here is correct, if it really does fall a total distance of 8,445 meters, we should be able to work out the final velocity upon impact, ignoring horizontal velocity, by using this equation here. Because we want to find the final velocity, we know the initial velocity is 0, we know the acceleration is 10 meters a second squared in that direction, and we know the total distance it has to fall. So I have v squared is equal to 0 squared plus 2 times 10 times 8,445. So v is equal to the square root of all those values there. So the square root of 2 times a times 8,445. You know, again, I think I should keep acceleration negative and the displacement negative. That way I do actually end up with the same answer. 2 times 10 times 845. That is equal to 410.9, so we'll say 411 meters per second. That is, in my opinion, a pretty good answer. Because recognize, as the rocket reaches this same level here on the way down, it should here be traveling downwards at 330 meters per second squared, so have a velocity of negative 330. Once it gets down here though, it's been falling this extra distance, it should have a velocity of a greater magnitude. In fact, I think I'll say the velocity is actually negative 411 meters per second, because that tells the examiner, I understand it is in the opposite direction to this velocity here, since I did take positive velocity to be in that direction. The hardest part of this kind of question is you either have to solve a quadratic or you have to split this question up into the upwards journey and then the downwards journey, because that's the only way I know of, without solving the quadratic, to get that t value out, to get those 2 times of the journey. So the purple journey being 41.1 and the yellow journey being 33.3. This may be the type of question you have to practice a few times. Best of luck to everyone.